Hello everybody, and how are you today? We're going to be looking at a NAD C370 amplifier and not an HP ProBook laptop, which is hiding over here because it is seriously water damaged and I can't be bothered at the moment, so we'll move on. You'll probably see a video on that at some point, but this is a complaint of no power or some weird delayed time of power coming on after you turn it on. One thing, that's your power button. It's green, like a dark green color, kind of. Just seems a bit strange, but I did look online because I thought maybe someone had replaced the on switch, and they are supposed to be a horrible green color, so it doesn't match the nice gray. But I've got it plugged in, so if we hit the power button, oh, I heard a relay click. I've got a green light, and the green light just went out. Is it another color, or is it out? Kind of looks red. It's red. Let's try that again. Green, off, fade to red. So I heard a relay click, so I don't know if that's the speaker output relay or what. But oh hey, look, a couple of more green lights while the power light's red. That's interesting. Relays are clicking when I do that. Maybe red is normal? It was a very quick on off click, I don't know. We'll have to get the lid off and have a look. I found these speakers A and B. And A's not lighting up, but B does light up. So maybe A and B are separately driven, and there's a fault with one of the output stages. Well, I do like the way they've laid this out. It's very clean looking, very easy to follow. The connectors are actually labeled. Each pin is labeled as well, which is handy. And it's sort of obvious where each section is, with the couple of power modules there and there, output modules. I'm not sure which speakers each one drives. There is spots of glue on the board in a couple of places that has turned a dark color, and that can become conductive and be a problem. There's some down around the heat sinks there. One's connecting the heatsink to a jumper wire as well. Some of those jumper wires have corrosion, oxidation on them, like down there and over here. But other than that, she's all very clean. A couple of signs of areas of high heat around the board there. That large resistor there, for example, there's discoloration on the board, so there could be dry joints in places. A little bit of a vacuum for the dust, and start disassembling and see what we can see. But I might start with checking power supply. So this should be plus or minus 64 volts, and it's the same on that side. And here we have plus 64, minus 64.7, 64.7, nicely balanced there. And that's a shared power line to the other side, so I don't need to check the other side. Let's have a stab at some of this brown glue, just see what condition it's in. Yeah, look at that, it's gone conductive. That's 39 megohms, but that can upset things quite easily when it's in places it shouldn't be. Having a further look, this line that carries the plus and minus 64 has one other wire, which is our output. So this is our right channel amplifier and this is our left channel on the other side, oddly enough, even though it's on the right hand side. And yeah, that's our output. So this is before the protection relay. We can check if there's a DC offset on there right now. So we just need to go from ground to the pin marked O/P for output, and we've got nothing there. That's a good start. And if we check our left channel, we've got nothing there as well. So that's a good start. So we're going to put a signal into it, just out of curiosity, and see what we get off speakers B. Got my signal gen. And I hear nothing. Oh, still nothing. Let's get an oscilloscope out and see what that gives us. That was interesting. All of a sudden I had audio, and I thought maybe I bumped something, and I was sort of tapping around again, and then there was a chattering, like a relay switching on and off rapidly, and it's gone. I think there could be, maybe it's bad caps or something. Maybe something's taking a while to charge up, and then it couldn't maintain it, so it's died off again. Let's do some measurements around still, but scared the crap out of me again. So let's see if that, this is looking like bad caps, but there were some chattering relays. Let's see which relays chatter. Is it the speaker ones? But the way the audio broke up, it was like it was the speaker relays chattering, like the drive to them couldn't maintain the coil voltage. This little module, I've got my eye on this little module. There's a lot of heat coming off this. There's it looks like a capacitor with a very shriveled up skin on it. That capacitor there is very hot. I'm thinking along those lines. Yep, I just heard everything just chatter off and disappear. Okay, I'm going to head down that way and check out what's going on in here. So I found the service manual, and indeed that little module standing up there is a protection module. And I looked closer at it and I could see the word protect module written on it, so we're on the right track. It's the module that activates the output relays, and that's what seems to be the problem, is the drive to those relays. So the fact that I can get a lot of heat coming off that module, I don't think that's normal at all, so we need to have a look at what's going on there. And this is how an amplifier should be built. There's a panel. You can open the panel and get access to the bottom to desolder bits. It's quite annoying when you have to dismantle the entire thing just to do one little job, but we got lucky. Now, having a look here, these are the pins for the module, our protection module. We've got a resistor with one end here that's pretty much completely disconnected from a dry joint, so there's been a lot of heat in there. And what this does is it goes over to a couple of transistors here, and that forms a 12 volt regulator circuit. So we've got 34 volts coming in from one end, and that's being dropped to 12 volts. So I think though our relays are running on 24 volts, but that 12 volts does play a part in things. So if that's not accurate and present, one of these is 12 volts. So I think the first thing we should do is clean up the dry joints and flick it on again and see what happens. But I think we still need to take the module out to address why those capacitors are running stinking hot when it looks like all it's doing is just a little bit of bypass filtering. It shouldn't be too hot to touch. I touched up a few other joints in the general vicinity as well as refreshing the ones on the protection module, so let's turn it on as is, just see if it's made any difference. Okay, so our power light still goes out to red, and we don't seem to have any control over the speaker relays from the processor, which is interesting actually, because that would probably work with that module perhaps. I haven't really studied the diagram much. Alright, let's get that module out. Now we had to unsolder the frame around it as well, but not too major of a job. And let's remove that. See what's going on underneath. That's pretty bad. There's a lot of dry joints going on underneath there. There's been a lot of heat in this module. There, up over here. We'll show you under the microscope. Starting up the top here, we zoom on in. You can see how horribly dulled the soldering has become, even though it looks sort of shiny under there. But here, if I wiggle that part, that's going to lift. That's going to crack right around there. I'd say it'd be forming a high resistance already. What else have we got? If we come over to the side, and here even, you can see a ring forming around here, and the one below it even, and more discolored solder. That one's nice. Yeah, this here, in fact you can see the crack in it already from that angle. If I come right in, you see that line scooting up around the side there? So that's on our diode. And what else is going on? Yep, some down near the pins. This entire board needs to be flooded with new solder, so we will do that. And what I'll do, actually, this is the capacitor that's getting really hot. In fact, look at this one. Check that out. That has been so hot that it's all just shriveled up and started peeling off. I won't rip it off, I won't be able to read the value on it. I think that'll need replacing. I can't see a value on that anyway. Holy moly. I think we'll hazard a... oh no, we've got a circuit diagram. What am I thinking? I'm not going to guess anything. We'll have a look at the value. It's possibly going to be the same as the one beside it, which is a 4.750 volt. But I think we need to check all of these and I think replace them, to be honest. This is just a bypass cap on the IC. There's a wire link that goes to this IC. I think that's the voltage, main voltage feed to that. I think that's one of these is a Zener. Anyway, alright, let's get those caps out, check them, resolder everything, and see what happens. So the one that was getting hot checks out at, now it should be 47 microfarad. Okay, 39.5, so that's down on capacitance. Should be 47. And the ESR on that, which I have a separate meter for, saying 1.6 ohms. So what have we got? 47 at 50 volt. Yeah, it's about an ohm higher than it would be desirable, so we'll replace that one. Now the one with the skin melted off is, according to the schematic, 10 mic 50 volt. So we'll put I got a 10 mic 63 that I'll put in there. I couldn't tell, I had to look at the schematic for reference to which pin was negative. That the positive lead went to the cathode of the diode, which appears to be, as I thought, it's a Zener diode off the 34 volt line to create a 24 volt line on this capacitor. Picking that diode is actually okay, but think about what action a high resistance dry joint would have on a Zener diode. It would not be able to pull that 34 volts down, would it? So it's possible there was an over voltage situation going on and causing all sorts of problems, and then maybe as heat got into the thing it caused the joint to, well, expand. The solder expands as the metal expands as it heats up, and conduct, and then bring the voltage down to a more acceptable level, which is when everything tripped in. Don't ask me what's caused it to trip out again, but something's falling out of balance there. We'll clean up the solder joints on the diode while we're here. Alright. Loose enough. So according to the little chart, 4.7 at 50 odd volts. I think it's 50. Yeah, it's 50. Should have a reading of, if I can get my leads, get the pins to stay on there, should have a reading of about 5 ohms, but it's not reading anything. It is really high resistance. Put the leads together, make sure it's working. Yep, good. Alright, let's go for capacitance. And my camera battery is about to die, so let's make this quick. It's probably not going to show much capacitance at all. I'm getting 19 nanofarads off a 4.7 microfarad cap, so that one is toast. Well, it's looking pretty good, mostly cleaned up there. The end of that resistor, it had become so hot that it's actually lifted the trace slightly, but it's still fully connected, so that should be okay. But yep, all new fresh solder. This capacitor tested absolutely fine, so I'm just going to leave it there. The rest are new, and let's see what happens. Right, let's plug it in and see what it does. Turn it on. Green light. Ah, I hear relays clicking when I do that now. And that relay clicks too, but we don't have a speaker A light. That's interesting. So we may have a problem perhaps with the light, but we do have relay control for the outputs now. Interesting. I wonder why that light would give up. Anyhow, let's maybe it comes on by default. What if we turn it off? Turn it on. So it's probably on by default. I turned it off with B lit up, but it didn't come back on lit up. So yeah, interesting. Let's get a signal on this and see what happens. Okay, I've got my Signal Gen app, and I'll switch it on. We're hooked up to speakers A at the moment. Here we go. Balance works. I don't have a second speaker in, I've only got one in at the moment. We can turn it off, on. Now, speakers B just sets them up, I think. I haven't looked into it. It might be in parallel. But it does run them together, so we've only got a left and right channel amplifier, and we only need to really test one lot to know that it all works. So I will put the speaker into the other side and double check the other channel. There we go. Right channel works. Alright, that was a nice easy one, wasn't it? But it's another one. And let's have a look at what's probably causing the light to not work. Look, it came on. So there's a dry joint down there. You can make it fade on and off. Okay, we'll take the front panel apart, resolder that, and call it a day. So for the front panel, there's actually screws hidden under this edge that's stuck on here, this fabric edge there, and some along the underside. There's a few along the underside, so undo those, and it feels like it's coming loose. Give it a wiggle, and I'm feeling it may... Is it retained by the knobs? Or is it just sticky? No, it's just sticky. Bit of prying, here we go. That opens up the... Oh, the LEDs are on that main board there. I was trying to see if I could maybe solder it from behind without having to take that off. It gives us a better idea as to where they sit. Here's the LED here. That's the one in question. Can I see it from the back side? If I wiggle it, I don't really see the solder joints wiggling. It could just actually be a bad LED. I have seen LEDs go bad, so got the shroud off it, so we'll turn it on. There we go. I think it's the LED itself, because there's definitely soldered on all right there. I think it's just a bad LED. nothing I can do about that except to put another one on. But do I have one? If I wiggle the parts around it, what about that resistor there? No. Wire joins? No. No. Oh, it's that resistor below it. That resistor is super loose. So honestly, don't do what I did and take these screws out and try and fight with getting this board out. Just undo the panel, this whole bracket panel at each end, and you've got to take the nut off there and the nut off the volume pots and adjuster pots, and then unplug a couple of plugs. You've got your mains plug there, and she'll swing out. You'll get all the access you need. This is one of the strangest places for a dry joint that I've ever seen. There's no real movement down there. There's no heat. It's almost like it may have had a lack of solder from the factory, perhaps. I don't know. But there we go. Let's get both ends of that. I'll do the ones beside it just in case. So I'll put a bit of flux on there so that I can just load the tip up with solder and just implant it there. And the LED itself is definitely not dry jointed. There we have it, all back together and lit up as it should be. All functioning. Perfect. Well, hope that helps you fix your NAD C370 amplifier. Thanks for watching, and stay tuned. Maybe we'll get that laptop video done for you. Catch you later.